Well, thank you very much. I'm calling this a 4D view of physics education. You'll see what I mean by that. But first, I really want to say this is a tremendous honor, and it's an honor that I was not anticipating in any way. So I really want to thank the awards committee. I want to thank Mary for that very nice introduction. I want to thank my collaborators, who I will show you in a moment. And most of all, I want to thank my students. They really are the motivation that gets me up and gets me thinking about how to do what I do best. Many collaborators over the years. These are, roughly speaking, in reverse order of who I've been working with, going all the way back to Gregor Novak, who is really my mentor as a physics teacher. And this really just scratches the surface of all the people that I've worked with over the years. I want to thank those who have funded me as well. So this could have been a very different talk. When Mary emailed me and let me know that I was winning this award and that meant I was going to have to give a talk, the first thing I did was I looked at the list of prior winners. And, you know, the result of that, first of all, was to be intimidated. And second of all, was to realize that I'd been scooped on almost everything that I know anything about. So previous winners have talked about everything that I'm an expert in. So that really leaves me with the following goals. Instead, what I have to do is really talk about university education in general, and I will touch on high school teaching as well. I don't have the guts that Tom has and that many of you have to actually teach in that environment every day. But I've worked with a lot of local high school teachers over the years, and in fact my sister is a high school teacher as well. So I know a little bit about that environment. I'm going to be talking about physics education in particular, but I'll start with the university in general. It's not always a pretty picture. There's going to be some tough stuff in here. In some cases, I'm going to be quoting people that I don't necessarily agree with, but what's out there is out there, and we need to be aware of it. But you'll find that there is hope, and I hope to communicate that by the end. So that was my introductory remarks. So, maybe my talk is 1/5 over. But what I want to do next, I want to start with the outside view. But actually, before I start the outside view, I want to introduce you to Jake. Jake's a student that I met when I was in the Associate Dean's position for undergraduate programs. Jake was a biology major. I met him as a freshman. An absolutely great student. A nice guy, top GPA in high school, great SAT scores, a boatload of AP credit. But during that first year, he had a really serious family crisis. And I can't possibly go into the details, but it involved both health and finance issues. And the result was that he withdrew from classes and went to work in his family business, which was a restaurant. But now I'll come back to Jake. But first, I want to point out that teaching physics, being a physicist, is really not a bad deal. The 2016 survey of what Americans think is the most prestigious career, scientist is second after physician. And in fact, there's a similar, there are other versions of this kind of survey. And another one that I looked at lists scientist as number 4, and then professor separately as number 6. So there's a lot of respect for scientists and for physicists. But on the other hand, you get this. So this is an editorial cartoon from my hometown institution, the Indianapolis Star. And I was thinking, well, all right, maybe I better look at some other newspaper. The Star is what it is. But you know, you look at other newspapers, and you still see a lot of this. And in fact, if you look at the K-12 environment rather than university, it's not a lot better. And of course, scientists are supposed to be this prestigious thing, so maybe if we limit it to looking at physicists, it won't be like this. But no. In fact, you know, I have a PhD in physics, and I can flip a mean burger. You know, when years ago, the joke used to be about driving cabs in Boston. So let's leave the editorial cartoon universe behind. This is a political year, so I'll have to keep touching on this. You know, we all have heard that the newspapers are slanted. You know, the mainstream media gives you the left-wing perspective. So what is the left-wing perspective on university education? Well, you got, dear class of 2015, college has failed you. The economic price of college failures. Colleges are failing in graduation rates. You see the word that keeps coming up? Many colleges are failing to prepare students for their working lives. And leaving failing aside, liberal intolerance is on the rise in America's college campuses. That's the left view.
That's the left view?
So let's look at the right view. This is the fair and balanced stuff. College campus protests. This is the generation that will destroy America. Professor tells students Republicans raped America. Now you can pay to take a college course on how to eat tacos. Indoctrination's knocking. Colleges nationwide scooping up social justice. Could your college degree be worthless? This is the kind of stuff. And it's a problem. It seems we do have a problem. So that's the outside view. And we're going to have to understand this a little bit better. You know, we're problem solvers, so, you know, let's look into the background and see what else we can get out of this. So let's look at the inside view. That would be our views and our students' views and maybe our administrators' views. But first I want to remind you about Jake. So Jake returned to school the next year. And after 1 month, the financial aid office got in touch with him and told him that he'd been retroactively denied all of his aid because he had dropped all of his classes the previous year. So he dropped all his classes again and left, returned to the working world. You can imagine what, you know, and this is not an uncommon story. You know, I'm picking on Jake because he's someone I knew. But after he leaves, what does he get but a bill for the 1 month of classes that he took? So now he's got a debt as well as everything else. This leads to this kind of thing. You know, there's all kinds of college reviews by students online that you can find. And this is just a smattering of stuff. These are not my institution, but these are institutions that I would send my sons and daughters to. If I were to list all the complaints I have about this money-gobbling corporation operating under the guise of an elite institution, and this goes on. This is a multi-page essay that begins that way. Campus looks like it was designed by blind architects taking a bet on who can create the ugliest and most impractical buildings. Faculty here is less than helpful, and they're extremely arrogant. When you ask politely for anything, most of them look at you like you're wasting their time. And, you know, this kind of stuff, there's thousands upon thousands of these things. And just so you know, it's not everybody else, it's me. So these are from my most recent set of evaluations. The handwriting was at best bearably legible. The recitations are a waste of time. The exams are unfairly difficult. Any of you ever have that kind of? I just really need to pass. I want to move on to the next butt-hurting physics. And this course is called Mechanics. Why the F are there 3 chapters of waves and harmonic? Obviously, this guy's an expert and knows what should be in mechanics, and I messed it up. So that's what students think. What about faculty? Well, you know, faculty, we do know what students should take, you know, what should be in mechanics, so what should they know? They should know mechanics and E&M, right? Relativity and quantum mechanics, that's part of a physics major, thermo and stat mech, or thermo and/or. And of course, they need to know some math, and probably chemistry, and of course, the writing and speaking skills that they'll need in the working world or in graduate school, and all the other gen ed stuff, and lab skills and common instruments and experimental design and data analysis, and how to write it all up in phys rev style, including doing it in LaTeX, and programming, and some, you know, some math programs, and LabVIEW, of course, is critical, and research skills in general, and the history of physics, and how science works, which is not a small thing. And faculty, of course, should know all that stuff. And everything they need for their research, and all the university or school district policies under which they operate, and the latest on teaching and learning. That's why you're here, right? To pick up on that one bullet point. And of course, you need to understand your students. And students know, for instance, that email is an old technology that only old people use. It's not really an appropriate way to even communicate anymore. And Facebook is also like that. And Vine will be old tech next year. And the year after that, it'll be Pokemon Go. And that didn't help, did it? No, that really didn't help. So I'm going to have to go to, you know, one of the other dimensions. And what's the other dimension physicists would do? It's the time series. So let's look at how some of this stuff plays out if you think of it in terms of time. So Jake returned to school a 3rd time. And he got his aides straightened out with some help from my side. By this time, I had left the dean's office, and my successor, a colleague of mine from biology, is now in that seat, and she helped him get his aides straightened out. And he passed some classes, including the following semester getting an A in physics in our algebra-based course. He didn't take my course, but he got in touch with me to let me know that he had aced physics. And in fact, he did it again. You probably also heard this narrative that college is exactly the same as it was 100 years ago. And of course, lectures the same as they were in ancient Greece, right? You've heard that story. And there is a grain of truth to this, I will agree. There are aspects of college that are much like they were 100 years ago. Except that, say, in the US, the number of students, this is the number of students registered for college classes in a given year, and it's increased by an order of magnitude since the end of World War II. The population of the US has only increased by a little over a factor of 2 in that time, and before World War II, without the GI Bill, it's only steeper going down. And the problems that students are facing, well, this is how a Pell Grant compares to the average tuition at a public 4-year institution. So college is not getting more affordable. You know, that is true, and there is a real criticism there and a real problem. You could blame this on the federal government, you could blame it on the states, you can blame it on the left or the right, wherever you want to blame it. The fact is, our students still have to deal with it. And the methods we use, I know you can't read all of this, but what this is EDUCAUSE does an annual survey of what technologies are used in education. And what this is, all the way to the right, this is by percentage. And the question was asked of students, what percentage of your classes use these technologies at least once? So number one on the list is search tools to find references for information or other outside of class work. And it's over 80% that use that. And then the next one down is learning management systems. And it keeps going. The fourth bar down, which is still 65%, is using laptops during classes. And then there's e-books and e-texts. And further down, there's lecture capture and using tablets and simulations or educational games. And all the way at the bottom, down around 15% is 3D printing and e-portfolios. And the dots represent things that students wish we would use more, or things that they feel like they'd be better prepared if we used more. So there really is a lot of use of technology in education. That could have been my other talk, by the way. And then, of course, I actually have a whole terabyte here. But I'm not going to show you the 5 gigabytes of slides that are about all the other problems that we face. Declines in funding, university infrastructure, high school infrastructure as well, student preparation, students' work ethics, campus or district or other administrative emphasis on stuff besides what we know to be the core principles that should be part of an education. So I'm not going to show you that stuff. But it's there. So what about another view? We'll just try one more. So the question is now about learning. Are our students even learning? What would that mean? It's really hard to measure the most important stuff. In fact, I would argue that the more important an educational goal is, the harder it is to measure. It's easy to do things like the force concept inventory. So you find out what students learned about a fraction of a single course. And you take a snapshot of it once, or maybe a few times over the course of a semester. But what about things like retention over years? What about development of underlying skills that are going to serve students throughout the rest of their academic or work career? Or the development of motivation or work ethic or professionalism, whatever these things are. These things are intangible, they're long-term, they're incredibly hard to measure. I can't do it. So what I'm going to do is look at a few long-term outcomes. So you remember how the number of students was increasing kind of linearly? Well, it looks like the number of degrees being earned looks more exponential to me. Maybe the doctoral degrees down there in the shorter pink bars are ones that are going up linearly. This data is, by the way, from the National Center on Education Statistics, and it goes all the way back to essentially just past the Civil War. And there's all kinds of great stuff on there. I had about 15 of these graphs, and I had to cut them all. Tom showed some great data that showed that more and more students were taking physics in high school since the late 80s, I believe. Well, according to the AIP statistics, things were going up and down for a number of years, but since the early 90s, they've been going up linearly. I think that's just the natural time lag between high school and college. So getting more students into your classes in high school, those of you who are high school teachers, thank you, because it's working. You're getting more students to major in physics. It's a great thing. And this is going up unabated for 20 years or so now. There's not a lot of data about the GRE. In fact, physics, they have less data than they have about a number of the other subject tests. But on the physics subject test for the 10 years that you can get data, the average scores are going up. And this is worldwide. You've got GRE takers from all over the place. But, this is somebody's learning more physics than they were before. I think that's a good thing. And in fact, this is really interesting. I was on the GRE website looking for data, and it turns out you can get data on how students break down by major on the general exam as well. And guess what? Physics and astronomy majors are #1. And this includes the writing part. And there's all those other exams, like the MCAT. Lots of you help prepare students for the MCAT. Physics is #2 there. And then there's the test that students take to go to business school. #1 again. And law school, #2 again. We got the Olympics coming up. That looks to me like 2 golds and 2 silvers. I'm pretty happy about that. Those aren't physics tests, and our students are doing really well. And then there's the AIP studies of what physics students are doing 1 year out. Well, 58% of them are going to graduate school and professional school. That's not bad. Not a lot of other fields accomplish that. And then there's the 38% of them that go into employment. 21% of them are joining the ranks of teachers in the K-16. They're helping train the next generation and keep those 2 graphs moving up. And then 61% are going into the private sector. And they're doing engineering, they're doing computer and information systems and IT, they're doing other work in physics and astronomy and other STEM, and then there's the 30% in non-STEM areas. And you sew all these things together, and the AIP, I'm sorry, one intermediate slide. There's all these wonderful job titles that they have. I'm not going to go through this in detail. But the AIP does survey all these people and ask them about their job satisfaction. And most of these bars, on job security and level of responsibility and opportunity for advancement, these are all the 75 to 80, 85% range. That's great. And I think it's really interesting. Look at the lowest, the low one, quote, this only just a shade under 70% is intellectual challenge. So whatever we're doing to our students, they're getting out there into the private sector and feeling like they want more of an intellectual challenge. That's a good attitude. You could wish they had more, but whatever it is that we're doing, our training, it's working. They want to be challenged. They're getting good jobs, and they still want a better challenge. Now, why is that? Well, it's because they learned all that stuff. And all of that stuff, well, most of that stuff anyway. No, we challenged them. We held them to really high standards. And, it's hard to measure, but I think it's fair to say that if we look at our students, and you talk to your students, you really look at them, and you compare how they were when they graduated to how they were when they first started out in college or in high school, they're learning. They're developing those good attitudes. They're wanting a challenge. And then there's Jake. Well, Jake earned his bachelor's degree in biology and got accepted to medical school. And in fact, in 2018, I expect him to earn his MD. And somewhere while he was working in that family restaurant, he met a girl. And he invited me and several of my faculty colleagues and the next associate dean to his wedding last summer. So he's appreciating it. So conclusions, higher education does have an image problem, as does high school, and as does physics a little bit. And this view is shared by many students, and that doesn't make our jobs any easier. But we have really high expectations of our students, and teaching physics is still worth it, and our students are learning, and when they graduate, they are thriving. So thank you very much. Have I got a couple minutes, Mary? I've got 5 minutes for questions, so have at me. Yeah, Bruce?
That was wonderful.
Thank you. I hope so. And the reason it's wonderful is because you're all wonderful. And I really think everyone in this room should take that to heart, that you're doing something really hard and it's really working.
Give you a big hug for that story about Jake.
Well, I'll come up and visit.
Associate deans, you run into that
Yeah,
same problem all the time.
yeah.
Do you have any thoughts or specific thoughts on what can be done for financial aid, about financial aid policies in particular that help with
Yeah. What can be done about financial aid policies? Well, I know that when I was associate dean, I and my counterpart, who was the associate dean for the College of Liberal Arts, made an appointment to see the director of financial aid. And we had at her, and Jake was one of the reasons why. And we brought his case up. And it turned out that there was a lot that you could do. Some of it is intractable. Some of it's governed by federal programs, and you can't change it. But a lot of it, it turns out, has to do with local policies that have to do with things like how audits are running. So I'm going to thank you. So this is going to eat up your time, Mary. So we started looking into this, and one of the things that we found out from our director of financial aid was that they were sending those letters denying aid to students, to an extraordinarily large number of students, and then overturning more than 50% of them on appeal. Which, yeah, oh great. So not only was it a squeaky wheel thing where the students that just took the university's word for it were the ones that were getting hammered unnecessarily, but they were creating extra work for their own people that had to review all those cases. And we convinced her to change the way that they did the audits so that they sent out way fewer of those letters. And then the ones that they did send out, we helped her to rewrite the text of the letter itself so that it wasn't this bureaucratic hammer. It was something that was saying, you know, we found a problem and we need to audit this. We would like you to come in and discuss this thing instead of, you've been denied this. And then, you know, in 8-point type at the bottom, if you wish to appeal, call this number. So yeah, there is a lot you can do, and a lot of it starts with just working with the financial aid people. They mean well, but they don't have the same level of direct contact as faculty do. So working with them is a good way to start the process. Yeah. Another question. Yes.
I like how you wove in Jake's story and everything, and I know at our school we're always being told, I work at Dutchess Community College, by the way, that we need to get better about telling our story as physics teachers and as faculty. I was wondering if you had any suggestions about that.
So, okay, so that could mean several things to several people. You know, I may not be getting what the question was, but basically the idea of telling our stories as physicists and as faculty members to our students, I think it's critical. One of the talks that this might have been is about forming a personal relationship with students. Most of our students value the personal relationship with their instructors much more than the average scientist. You know, I don't have statistics on this, and I like to do things by data, but I will echo, because I think it is true, there is some truth to that joke about physicists. You know how you tell an outgoing physicist? They're the ones that look at your shoes while you're talking. And, you know, the same joke gets told about engineers and lots of others. But the fact is, students really want that personal